question. There were two questions, and the second question is depending on the answer of the first question. Consider the following DFA. One DFA is given: Q0, Q1, Q2, Q3, Q4, Q5, Q6, Q7 are the states, and Q6, Q7 are the final states. Q0 is the starting state. The number of equivalence classes with respect to the above DFA is options are 4, 5, 6 and 7. So here for every state usually one equivalence class will exist, but the correct count you will get the proper number of equivalence classes, because when you minimize the number of states. Okay, first of all you have to minimize the number of states. In a minimized DFA, if you have n number of states, there exists n number of equivalence classes. So first you have to minimize it by writing the delta. So delta is given like this. So inputs are A and B, states are Q0, Q1, Q2, Q3, Q4, Q5, Q6 and Q7. These are the states. Q0 on A is Q1, Q0 on B Q4, Q1 on A Q5, Q1 on B Q2, Q2 on A Q3, on B Q6, Q3 on A is Q3, B is Q3, Q4 on A is Q1, Q4 on B is Q4, again Q5 is Q1, Q4, Q6 is Q3, Q7, Q7 is Q3 and Q6. So this is two states are equal if the reaching pair is same. So Q1, Q4, is it repeated anywhere? It is repeated here and here. That means Q0, Q4, Q5 is one equal pair. Q0, Q4, Q5 is one pair. That is can be taken as a single state. Next that can be taken is Q3, Q6, Q3, Q6, which are for state Q2 and Q7. So Q2 and Q7 are also same. Q2 and Q7. All other are different pairs. So what are the leftover states? Q1 and Q3. Okay, Q2, Q6, Q7 are the states, both are final. Okay, total how many states we got? Again one more state is left over, Q1, Q3 and Q6 also. So total there are 5 states. When you have 5 states, we will have 5 equivalence classes. So B is the right answer. Option B is the right answer. In a minimized DFA, when there are 5 states, then we will have the 5 equivalence classes. Accordingly, we can define the transitions also. There is another question which is linked to this. What is the classification of equivalence classes corresponding to non-final and final states respectively, using correct equivalence classes above? A. 3 non-final, 1 final. B. 4 non-final, 2 final. C. 4 non-final and 1 final. D. 5 non-final and 2 final. So here in the previous we got total 5 equivalence classes. Out of the 5 equivalence classes, we got one final state equivalence class, because there is only one final state. Q2 and Q7 is clubbed into single state. Remaining non-final states are Q0, Q4, Q5 is one non-final state, and then Q1 is one non-final state, Q6 is one non-final state, Q3 is one non-final state. Total 5 states. So one final state equivalence class, remaining non-final state equivalence class. So 4 non-final, 1 final. Option C is the right option here.